Let's go back to binary to consolidate this new passion that you have. To create a subnet, you need to borrow host bits and use them as subnet bits, as shown in this figure. They must be taken consecutively, starting with the first on the left. Here we have a network address class C standard which is not divided. As a reminder, the default mask for a C class is /24, that is to say 255.255.255.0. We will be working with the network 192.168.3.0.0 with a /24. This means that there are 24 bits at 1, which gives a decimal 255.255.255.0. The network therefore extends from 192.168.3.0.0 to 255. As the first address is the network and the last the broadcast, it is possible to use 254 IP to guests, because 256 minus 2 gives us 254. Now let's say that we want to create a subnet by borrowing a bit from the host part. On the fourth byte, we now have a 1 followed by 7 zeros, which gives in decimal the number 128. The mask will therefore be 255.255.255.128. As in total there are 25 bits at 1, the network will be written 192.168.3.0.0/25. If we change all the bits to 1, where the separation took place on the network address, we find as a broadcast address 192.168.3.0.127. It will therefore be possible to use 126 IP for the host's part, because 128 minus 2 is indeed 126. Each time a bit is borrowed, the number of subnet addresses increases, and the number of available host addresses per subnet decreases. The algorithm that is used to calculate the number of subnets and hosts is the power of 2. Borrowing a host bit is equivalent to making 2 powers 1, which allows you to create 2 subnets. By borrowing 2 bits, this gives 2 powers of 2, and therefore makes it possible to create 4 subnets, and so on. Now we will take the same example, but this time with an address class B, 172.168.1.6.0.0, with its default mask of 1.255.255.0.0. Here is what we have to do with large networks of more than 65,000 IPs. The mask in /16 allows us to have exactly 65,534 usable IPs for hosts. That is to say, after removing the network and broadcast address that cannot be used for hosts. If we want to cut this network in two, we will also have to borrow from it a bit of hosts. As with a Class A address, each bit borrowed doubles the number of subnets. Prefix length changed from /16 to /17, we now have 2 subnets which can each contain 32,766 usable IPs. You can see that if we borrow 6 bits at an address Class B, this makes it possible to have 64 subnets of 1,022 IPs that can be used for equipment. And here is a last example, with this time a Class A network, which consists of a default mask in /8, which represents very large networks of more than 16 million IPs. The principle remains the same. Each time a bit is borrowed, the number of subnet addresses increases, and the number of available host addresses per subnet decreases. So we want to borrow 2 bits to be able to create 4 subnets. If a network address is split, then the first subnet that is obtained is called subnet 0. Here it is, the 10.0.0.0 network. To determine each subnetted subnet address, the network address must be increased by the value of the last bit that was borrowed. In this example, 2 bits are borrowed for the subnet of the same network address, 10.0.0.0. The first subnet address is therefore 10.0.0.0. This is subnet 0. The last bit borrowed is the one with the value 64. So the next subnet address will be 106400, then 1012800, and the last one will be 1019200. Now that we have our network addresses, we can deduce simply the broadcast addresses. This is the IP address that precedes the next network. And finally, we can note the IP address ranges usable for a host for each of the subnets. Do not hesitate to train yourself to fully understand the role that the subnet mask plays.